All right, welcome. In this video, we're going to be solving rational equations. And so, in the previous video, we simplified rational expressions, and that was largely so that we could, solve certain equations. And so I'm going to really just go through a bunch of different types of equations that we need to be able to solve in this class and show you that, some of them we already have experience with, like this 2x plus 1 divided by 4 equals 7. I really think that this is something that we were able to solve all along in this class from kind of the first days of school to now. We're going to start by multiplying both sides by 4. And so I'll have 2x plus 1 equals 28. I'll subtract 1 to get 2x equals 27. I'll divide by 2 to get x equals 27 over 2, or 13.5. And that should seem pretty familiar, right? We've done that before. This one on the right, I assume that you have solved equations like this before in your life. I think last time I taught it, I think was when I was doing Math 7. But solving proportions is something I know you have experience with. And I don't know what your teacher told you to do the last time, but I'm going to tell you to just cross multiply. So we're going to multiply 4 times 3 is 12, and that's going to be equal to 3 times x minus 4. Really what we're doing here when we cross multiply is we're multiplying by both denominators. Okay, so I'm multiplying by an x plus minus 4 and a 4, so the 4's cancel, and I'm left with a 3 and an x minus 4, and then on the right side I'm multiplying by a 4 and an x minus 4, so I get 12 and the x minus 4's cancel. And that's what's going on with cross multiplication. I kind of fumbled over that when I was discussing it in class, but cross multiplication is completely legitimate. Okay, so what I'm going to do is I'm going to distribute that 3 to have a 3x and a negative 12, and then I'm going to solve this equation the old-fashioned way. I'm going to add 12 to both sides. And then I'm going to divide by 3. 24 divided by 3 is going to be 8, so I'll just say x is equal to 8. Okay. These are two of the more basic ones we're going to look at, but I think it's definitely good to start with what we're familiar with. So let's move on a little bit. These are two more that can be solved with cross-multiplying. One thing I am going to point out before I go any farther, though, is that sometimes this can return extraneous solutions, these rational equations. And where that would happen would be if your solution that you got, this x equals 8 here, caused you to divide by 0 in the original statement of the equation. But I'm checking that visually. I'm not seeing any division by 0, so I'm happy x equals 8 is a solution. Over here, I don't have anything to worry about because there's no place to divide by 0 because all we were divided by is 4. So that's not really relevant to our discussion. But I didn't want to go any farther without saying that. So over here, just like to think about what's going to happen, if I get x minus 5 or x equals 0 as a solution, that would be an extraneous solution. But I think this is a good place for you to try this on your own. So you should pause the video and try these problems because the answers are going to come up in just a couple seconds. All right, there you have it. So these were two pretty standard cross-multiplication problems. Neither of them returned a solution that had anything wrong with it in terms of dividing by 0. So I've got an answer. I'm ready to move on. Okay. These next two, these have x's on top and bottom, and so they're going to incur a quadratic. And so I'm not sure that you've done any like this before, but I'm also not sure that you haven't. So what I'm going to do is, just like before, I'm going to start by cross-multiplying. So x plus 2 multiplied by x plus 1 equaling x minus 5 times x plus 6. And then I'm going to distribute, set the thing equal to 0, and solve. Oh yeah, this is not exactly a quadratic, but I know how to fix the next one so that it does become one. So I'm going to go over here and I'm going to say, all right, x squared. If I do FOIL, I'd have 1x plus 2 more x. That would be a total of 3 x's, and then I'd multiply the last, and I'd get plus 2. X squared here, outside would be 6x, inside would be minus 5x, so that's positive 1x. Negative 5 times 6 is negative 30. Okay, so I think I'm going to start solving this equation, and you'll see me take more than one step at a time probably after this, but I'm going to start by subtracting x squared from both sides. If I subtract an x squared from both sides, I'm just going to have 3x plus 2 equals x minus 30. And just lose the x squareds. And then I'm going to subtract an x from both sides, and I'll have 2x plus 2 equals negative 30. Then I'll subtract 2 from both sides to get at that x. So I'll be saying 2x equals negative 32, and as a result, x will equal negative 16. Okay, I go back, I check my equation. Is negative 16 going to cause me to divide by 0? No, it's not, so I'm happy with my solution. And this next one, I switched that to an x plus 2. Not because that's going to make you solve a quadratic equation, but because that's going to make something else weird happen that we haven't seen in a while in this class, and I need you to be reminded about. Okay, so I'm going to say, I want you to try this one on your own. Okay, so I'm going to just bring in the answers in a few seconds, so you should pause now and work it on your own. All right, there you have it. So if you whittle this one down, you cross multiply, distribute, start trying to solve at x, you'll get down to something like negative 12 equals negative 6. And that's never true. So that means that the original equation is never true. And so I conclude that there is no solution to this equation. It's been a while since we've seen one of those. Now let's do one that is going to have an extraneous solution. And maybe that will use those simplifying skills that we developed in the last video. Okay. So this is going to be a different one from the one you're seeing if you're following along in my notebook, and I'm just going to ask you to change the problem, because the one that's in the notebook is like the one I just did where it comes back no solution at all. And I like this one because it has solutions, but one of them's invalid. So what we're going to do is first, I'm thinking we're going to get a common denominator, okay, for all three of these terms. And I think what you want to do is you want to notice, okay, this is factorable. This is factorable into x minus 2 and x plus 3. And so what I'm going to do is I'm going to rewrite this, and I'm just going to factor the denominator, x minus 2 times x plus 3. And that's going to equal, okay, I need to get a common denominator on these things. So x over x minus 2 is missing something. It's missing that x plus 3. So like I told you last time, I need to multiply by some form of 1, so I'm not changing the value of the fraction. But I need to get it with a common denominator. So plus 2 over x plus 3. Well, that needs the x minus 2 in it, so I'm going to multiply by x minus 2 over x minus 2. And then I'm going to kind of like collect all of my terms and see what I've got. So I've got 10 over x minus 2x plus 3. Equaling, okay, distribute x squared plus 3x over that same denominator, plus 2x minus 4 over the same denominator. And then, you know, a person can combine these in with a common denominator, but what I'm going to suggest you do at this point is, now that you've got all three objects having the same denominator, let's just get rid of the denominator. And I'm not going to just tell you to do that. I'm going to explain why it's true. So what I'm going to do here is I'm going to multiply both sides of this equation by x plus 3 and x minus 2. And I'm feeling like I probably need to zoom out, and I'm going to need another sheet of paper to do this on the left. And that'll be good. Okay, so I'm going to go over here, and I'm going to multiply. Well, I guess that's fine. I'm going to multiply this thing also by x plus 3, x minus 2, all divided by 1. So maybe I'll just keep it the same over there. So x plus 3 divided by x minus, x plus 3, x minus 2 divided by 1. Okay, so I'm going to kind of over here where the paper's switching. It keeps flipping up. It's going to be all right, though. X minus 2, okay, all that to just show you why it's okay to clear out the denominator, but it's worth it. Okay, if I was to multiply, I'd multiply straight across. I'd have 10 times x minus 2 times x plus 3, and these are things that I could like cancel off, right? So, you know, I would cancel like this, and I would cancel like that, and I'd be left with 10. Over here, I would distribute this fraction to both of these. So I would end up with an x plus 3 and an x minus 2 in the numerator of both of these fractions, allowing me to, you know, get rid of all of these. So what we're going to remember, you know, when we're doing this, is that if we can get a common denominator on every term of a rational equation, then we can just completely clear out the denominator and go straight to 10 equals x squared plus 3x plus 2x minus 4. Yeah, I see where this is headed. Okay, now this is a quadratic with, x squareds and x's in it, so our only hope for solving it is by setting it equal to 0. So I'm going to subtract a 10 from both sides. I might combine the 3x and the 2x into 5x. And minus 4 minus 10 more would be negative 14. All right. And now I'm going to be like, okay, I'm really hoping I can factor this so I don't have to use a quadratic formula. If I can't factor, I can always use a quadratic formula. But I would prefer to just be able to factor. So what are two numbers that multiply to negative 14 while adding to positive 5? It's got to be 7 and 2. But since it's positive 5, it should be positive 7, negative 2. All right, so 0 equals x plus 7 multiplied by x minus 2. Okay, and that product would equal 0 anytime either of these was equal to 0. So if x plus 7 was equal to 0, the product would be 0. And if x minus 2 was equal to 0, the product would be 0. But if I go back to the original statement of the equation, x equals 2 causes me to divide by 0 right there. And actually right here as well. Okay, but we can't say that undefined equals undefined plus something that is defined. That's not going to work. Undefined does not even equal undefined, right? Equals is a relationship between two real numbers. So I'm going to go over here and I'm going to say, all right, x equals 2. That one's out because it's an extraneous solution. Okay. And I really like that example because it kind of had it all. It had the simplifying rational expressions like we were practicing, and it had the extraneous solution, and it had factoring and all sorts of stuff. And I think that's going to be all the examples I need to show you in this video. Really, I'm looking at all of these extra practices. I'm looking at the rest of the problems in the notes book, and those would be really good practice for you to work on your own. I don't think you need to watch me do any more, though. I don't think that would be a good use of your time. At this point, you should go and work a bunch of these equations and make sure you're doing it right. I would recommend you start with the homework examples because that one's got a video solution. But if you still feel like you're needing more, come over to these extra practices, and if you do them and you can't find solutions to them, bring them to me in the morning and I will show you the answers to them. But that's going to be all for this video. Thanks for watching.